Imagine you're driving down a road with a strict 30 mph speed limit. Your car's GPS tracks your distance and time, calculating your speed as exactly 29.8 miles per hour. Safe, right? Well, not necessarily. If that distance tracker rounds down to the nearest mile and the timer rounds up to the nearest second, your actual speed could easily be over 32 miles per hour, enough to trigger a speed camera. Hi, welcome to My Exam Revision. In this video, we'll be looking at upper and lower bounds. This lesson is divided into 3 sections. In the first section, we'll learn how to find the upper and lower bounds of single values using error intervals. In the second section, we'll look at how to find upper and lower bounds when two values are multiplied, divided, added, or subtracted. In the third and final section, we'll work through a more complex past paper question on upper and lower bounds. I'll show you how to approach it clearly and how to deal with questions that combine several steps.
I've added timestamps in the timeline below, so if you'd like to skip ahead to a particular section, you can do that easily. I've also included detailed notes in the description. If you'd like to go through the steps more carefully in your own time, you can click the link and follow everything step by step.
Now, let's get started. Let's start with a very basic question. We are given the number 74 and we are told that it has been rounded to the nearest integer. We are asked to find the upper and lower bounds. There are two important pieces of information. First, the number is 74. Second, it has been rounded to the nearest integer. The nearest integer tells us the degree of accuracy. Step 1 is always to draw a number line and find the intervals. Place 74 in the middle of the number line. Since we are given that the degree of accuracy is an integer, we will add and subtract 1 to find the next and previous interval. 74 plus 1 is 75. 74 minus 1 is 73. Step 2 is to find the midpoints of these intervals. To find the upper bound, we calculate 74 plus 75 divided by 2. That gives us 74.5. To find the lower bound, we calculate 73 plus 74 divided by 2. That gives us 73.5. So the lower bound is 73.5 and the upper bound is 74.5. Now the inequality is very important. We say 74 is greater than or equal to 73.5 and 74 is less than 74.5. We put the sign of less than equal to for 73.5 because if a number is exactly 73.5, it rounds to 74. But we use the sign of less than 74.5 because if a number is something like 74.49, it will round off 74, but if it is exactly 74.5, it rounds to 75. Remember the difference in the symbol. It is very important in exam questions. Now let's try a slightly more difficult example. We are given 75.5 rounded to the nearest 0.5. Again, we are asked to find the upper and lower bounds. The number is 75.5. The degree of accuracy is 0.5. Draw the number line and place 75.5 in the middle. Add 0.5. 75.5 plus 0.5 equals 76. Subtract 0.5. 75.5 minus 0.5 equals 75. Now find the midpoints. For the upper bound, calculate 75.5 plus 76 divided by 2. That gives 75.75. For the lower bound, calculate 75 plus 75.5 divided by 2. That gives 75.25. So we write 75.5 is greater than or equal to 75.25 and 75.5 is less than 75.75. So this completes part 1 of the video. After this section, you should now feel confident finding the upper and lower bounds of a single number for any given degree of accuracy. Before we move to the next section, I want to quickly mention something that will help you practice this topic properly. On my website, My Exam Revision, I have created a full worksheet for each topic. It starts with basic foundation questions, then moves on to harder multi-step problems, and finally proper past paper exam style questions, all with step-by-step solutions. I've also built an AI version of myself based on my 14 years of teaching experience in GCSE Maths, A-level maths and further maths. You can check the step-by-step solutions, and if you get stuck, you can simply take a photo and upload your working. It will analyze each step, highlight where you went wrong, and even if your final answer is correct, it will still check your method thoroughly. If you're serious about improving your grades, I highly recommend trying it. The link is in the description. Now, let's continue to the next part of the video. We will discuss upper and lower bounds with the 4 mathematical operations: addition, subtraction, multiplication, and division. Suppose you are given a number a and a number b, and you are asked to find the upper and lower bound of a plus b. To find the maximum value of a plus b, which is the upper bound, we take the upper bound of a and the upper bound of b. To find the minimum value of a plus b, which is the lower bound, we take the lower bound of a and the lower bound of b. This is because both quantities increase or decrease together when added. For multiplication, assuming both numbers are positive. To find the upper bound of a times b, we multiply the upper bound of a by the upper bound of b. To find the lower bound of a times b, we multiply the lower bound of a by the lower bound of b. For subtraction, the rules are a bit different. To find the upper bound of a minus b, we take the upper bound of a and subtract the lower bound of b. To find the lower bound of a minus b, we take the lower bound of a and subtract the upper bound of b. For division, if we have a over b. To find the upper bound of a divided by b, we take the upper bound of a and divide it by the lower bound of b. To find the lower bound of a divided by b, we take the lower bound of a and divide it by the upper bound of b. Now, let's look at a question using this. We are given a rectangle. The length is 12.4 centimeters, correct to the nearest 0.1 centimeter. The width is 8.6 centimeters, correct to the nearest 0.1 centimeter. We are asked to find the upper and lower bounds of perimeter and area. Part 1 is to find the upper and lower bounds of length and width. For the length, 12.4 plus 0.1 is 12.5 and 12.4 minus 0.1 is 12.3. The midpoint between 12.3 and 12.4 is 12.35 and the midpoint between 12.4 and 12.5 is 12.45. So the lower bound of length is 12.35 and the upper bound is 12.45. For the width, 8.6 plus 0.1 is 8.7 and 8.6 minus 0.1 is 8.5. The midpoint between 8.5 and 8.6 is 8.55 and the midpoint between 8.6 and 8.7 is 8.65. So the lower bound of width is 8.55 and the upper bound is 8.65. Part 2 is to find the upper and lower bounds of perimeter. The perimeter is 2 times the sum of length and width. So we will use the rule related to sum that we discussed earlier. For the upper bound of the perimeter, we will get 2 times 12.45 plus 8.65, that is equal to 42.2. For the lower bound of the perimeter, we will get 2 times 12.35 plus 8.55, that is equal to 41.8. These give the upper and lower bounds of the perimeter. Part 3 is to find the upper and lower bound of area. The area of a rectangle is length times width. So we will use the rules of multiplication of two numbers that we discussed earlier. For the upper bound of the area, we will do 12.45 times 8.65, which is 107.6925. We round to 3 decimal places, 107.693 as asked in the question. For the lower bound of the area, we will do 12.35 times 8.55, which is 105.593. Now let's try a question with different operations. In this question, we are given that a resistor has a voltage of 12 volts correct to the nearest volt. The resistance is 4 ohms correct to the nearest 0.1 ohm. The current is calculated using I equals V divided by R. Part 1 is to find the upper and lower bounds of voltage and resistance. For voltage, we will do 12 plus 1 is 13 and 12 minus 1 is 11. The midpoint between 11 and 12 is 11.5 and the midpoint between 12 and 13 is 12.5. So the lower bound of voltage is 11.5 and the upper bound is 12.5. Next, to find the upper and lower bound of the resistance, we place 4 in the middle of the number line. Then we add 0.1 to get 4.1 and subtract 0.1 to get 3.9. We find the midpoints between these values. This gives us a lower bound of 3.95 and an upper bound of 4.05 for the resistance. Now we move on to finding the upper bound of the current. Since current is voltage divided by resistance, we follow the rule for fractions. To find the largest value of the current, we take the upper bound of the numerator and divide it by the lower bound of the denominator. That gives us 12.5 divided by 3.95, which is approximately 3.165 when rounded to 3 decimal places. For the lower bound of the current, we take the lower bound of the numerator and divide it by the upper bound of the denominator. That gives 11.5 divided by 4.05, which is approximately 2.840 when rounded to 3 decimal places. We have now discussed 2 questions on upper and lower bounds using different mathematical operations. Next, we will move on to a more complex past paper question. Now let's look at this question. Ebony makes some bracelets to sell. The material to make the bracelets costs 190 pounds, correct to the nearest 5 pounds. Ebony sells all the bracelets at a total price of 875 pounds, correct to the nearest 5 pounds. The total time taken to make and sell all the bracelets is 72 hours, correct to the nearest hour. Ebony uses the formula for hourly pay, which is hourly pay equals total selling price minus total cost of materials divided by total time taken. The minimum hourly rate for someone of Ebony's age is 8 pounds and 20 pence. We are asked to determine, by considering bounds, whether Ebony's hourly pay is definitely more than 8 pounds and 20 pence. To answer this, we need to calculate the lower bound of her hourly pay. If the lower bound is greater than 8 pounds and 20 pence, we can be certain she earns more than that. First, we find the upper and lower bounds of the 3 quantities: selling price, cost of materials, and time taken. For the total cost of materials, 190 pounds, correct to the nearest 5 pounds. Add 5 pounds. 190 plus 5 equals 195. Subtract 5 pounds. 190 minus 5 equals 185. The lower bound is the midpoint between 185 and 190. 185 plus 190 divided by 2 equals 187.5. The upper bound is the midpoint between 190 and 195. 190 plus 195 divided by 2 equals 192.5. So the lower bound of the cost of materials is 187 pounds and 50 pence and the upper bound is 192 pounds and 50 pence. Next, for the total selling price, 875 pounds, correct to the nearest 5 pounds. Add 5 pounds. 875 plus 5 equals 880. Subtract 5 pounds. 875 minus 5 equals 870. The lower bound is the midpoint between 870 and 875. 870 plus 875 divided by 2 equals 872.5. The upper bound is the midpoint between 875 and 880. 875 plus 880 divided by 2 equals 877.5. So the lower bound of the selling price is 872 pounds and 50 pence and the upper bound is 877 pounds and 50 pence. Finally, for the time taken, 72 hours, correct to the nearest hour. Add 1 hour. 72 plus 1 equals 73. Subtract 1 hour. 72 minus 1 equals 71. The lower bound is the midpoint between 71 and 72. 71 plus 72 divided by 2 equals 71.5. The upper bound is the midpoint between 72 and 73. 72 plus 73 divided by 2 equals 72.5. So the lower bound of the time taken is 71.5 hours and the upper bound is 72.5 hours. Now we calculate the lower bound of Ebony's hourly pay. Hourly pay is a fraction with numerator equal to total selling price minus total cost of materials and denominator equal to total time taken. To find the lower bound of a fraction, we take the lower bound of the numerator and divide it by the upper bound of the denominator. The numerator is total selling price minus total cost of materials. The lower bound of the numerator is 872.5 minus 192.5 equals 680. The upper bound of the denominator is 72.5 hours. So the lower bound of hourly pay is 680 divided by 72.5, which equals approximately 9.38 pounds. Since the lower bound of Ebony's hourly pay is 9.38 pounds, this is definitely more than 8 pounds and 20 pence. Therefore, we can conclude that Ebony's hourly pay is definitely greater than 8 pounds and 20 pence. I hope you enjoyed this video. If you did, please give it a like and subscribe to our channel. We will be bringing out more educational content like this, so make sure to follow the channel. Also, don't forget to try the questions on the worksheet linked in the description. Thank you for watching.